Students, this morning we're going to be talking about Lesson 10.3, Symmetry. First, we're going to be talking about four different kinds of symmetry: line symmetry, plane symmetry, rotational symmetry, and axis symmetry. Line symmetry is the simplest. When you were a kid and you made valentines, you folded a piece of paper and then you cut it on either side, the shape of a half heart, and then you unfolded it. So that would be considered line symmetry. Anytime you can fold an image across a line and get the exact same thing, for example, this one left and right, like you did with valentines when you were a kid, that's called line symmetry. So take a moment and decide which one of these images have line symmetry, and more importantly, how many lines of symmetry. Take a minute to do that. Okay, this first image has line symmetry. Just one line, assuming that these were equal or not, should have been marked. This one, there is no line symmetry because if you go like this and fold, these corners do not add up. So this was yes, and how many lines? One. This one was a no. This one is a yes, one. One line of symmetry. This one has a line of symmetry going this way, and then a line of symmetry, so this was a yes. Two lines of symmetry. And this star has one, C star has one line of symmetry going that way. So line symmetry means you can take the image and fold it and get the exact same thing. Line symmetry. Then we have rotational symmetry. Rotational symmetry is where you can rotate a figure about a single point, an angle greater than 0, of course, but it has to be less than a complete circle. And the image coincides with the pre-image, means you can rotate less than 360 and get the same thing. Alrighty, so for example, if you have a square, the angle of rotation is the smallest angle that it can be rotated to coincide with the original. The order of rotational symmetry is the number of times the figure coincides with itself. So right here, this square, let's get a close-up because this is easy to understand. If I had a square, I only have to rotate it 90 degrees, and then this point, this red point gets in the same position as the blue point, and you have the same image. So yes, it has rotational symmetry. The angle of rotation from one point to the other so that you get symmetry is 90 degrees. And there's 4 times you can go through that 90 degrees and get the same image, so our order of symmetry is 4. Rotational symmetry. Now, apply what I just said to these figures. And we can see here that this first one, yes, it has rotational symmetry, but it has to rotate a complete 180. So yes, you rotate 180, you get the same image. Therefore, you only have 2 orders of symmetry, 1, 2 rotations, and the angle of rotation is 180 degrees. This M here, if you take this and you rotate, you have to go all the way around 360 to get the same image. Therefore, it does not have rotational symmetry. This snowflake, if you ask yourself right here, this point, and if they're evenly spaced, and it has rotational symmetry. If I rotate this way, this image comes up. I get the same image. And there's 6 of them. 1, 2, 3, 4, 5, 6. The order is 6. And of course, the angle of rotation is 360 divided by 6. And you get 60. This image, of course, if I go like this, It does have rotational symmetry. 3, the order is 3, and 360 divided by 3 is 120. So that's rotational symmetry. So far we've covered line symmetry, rotational symmetry. Now, plane symmetry has to deal when you're dealing with solids or 3D. It's kind of like line symmetry, but it's in 3 dimensions. So if you have a solid, let's say you have a square-based prism here, square-based prism. It does have plane symmetry because I can slice it down vertically and get the same image exactly, and I could also slice it horizontally. So it would have 2 plane symmetries. If you can imagine a slice going this way, it's kind of hard to see. So it has 2 different plane symmetry slices. The 4th one is symmetry about an axis. Again, this is only solids. That means you can drop an axis or a straight line down the center, and you can rotate it and get the same image. And again, you have to rotate less than 360 and get the same image. It will have what's called axis symmetry about an axis. So we're going to take a quick moment here. This first one, I'd like you to go ahead. I'll wait about 30 seconds to determine whether these have plane symmetry or axis symmetry or both or neither. Okay, the trapezoidal prism, I could slice it, if you can imagine, going down this way, going through. So I can slice it sideways once. So yes, it has plane symmetry, one plane of symmetry. Okay, the equilateral prism, it does have plane symmetry. Imagine slicing in 3D going this way, down the middle. And it also has axial symmetry. If I drop down here an axis down the middle, you have to think of that in 3D, and my rotation is going to be 120 degrees of axial symmetry. Cone symmetry, it has plane symmetry. If I slice it down the middle, like cutting a cone in half, and it also has rotational symmetry about an axis if I go straight through and rotate. Now this, remember this moment, because symmetry leads us into what's called solids of revolution. You're going to be working a lot with these in calculus, folks. Okay, so the idea of a rotational solid is you start with an axis. You have a 2D